called properties of logarithms. So our goal for this stuff is to be able to rewrite and simplify log statements in a couple of different ways. We're going to be what they call expanding logarithms and contracting condensing logarithms. And we use three basic properties. Three basic properties are nothing like, are more or less like this. Yeah, you will use this all the time. I just left myself a picture. I write it on the board for you. There are three basic properties of logarithms, and I'm going to kind of revert back to this each time. For example, if I have the log base b of things being multiplied together, u times v, it can be rewritten as the sum of their two logs. And I'll do an example of each one of these as we go along. Okay. For example, if I'm going to use that product property, yes sir?
What does the log represent?
Exponent. Remember, logarithms are nothing more than exponents. There's just other ways of working with exponents to solve exponents. When we're working with logarithms, it's what exponent is giving you that, well, to that base is going to give you that value of y. Logarithms are just ways of working with exponents. If I look at it, a simple example about product property, if I say something like the log base, I don't know, 2 of 3x, what that allows me to be able to do is break it into two parts. It allows me to break it into log base 2 of 3 plus log base 2 of x. The reason why we want to be able to do that is sometimes we can simplify things via the bases. And you guys have seen that throughout the past couple of days. Like the example you had with the log base 7 of 49, we were able to rewrite that right away and drop the exponent. By being able to use these properties, you can do stuff like that. Okay.
Wait, is that the?
Okay. If I look at the quotient property is talking about division. When we're talking about division, I need like a satchel. Carry all this around me. Jack Bauer's coming back, in case you guys didn't know. I better not talk too much about 24. The copyright infringement people might come after me. No, remember the show 24?
Yeah.
Jack Bauer carried a satchel.
About what's his face? There's his satchel.
Yeah, but 24 is better.
Wait, did
So-
they take your video down just for talking about it?
No.
You had a copyright try.
Yeah. Let's all sing the song about log. Log,
Everybody wants
log. Big, it's heavy, it's wood.
Wait, is that what it is?
They took it down because of the video. The video was Nickelodeon's intellectual property. I don't even want to see if you can use that as intellectual. But what happens there is that it wasn't, I don't want to say it wasn't cited properly. I might have been able to cite it. I'm not quite sure. I've never had this issue before. But it's like back in the early 90s when this thing on the internet called Napster first came out. I'm sure you might have heard of it. You ever heard of Napster?
Is that something like downloading?
No, Napster, what happened with Napster was a file sharing program that people, when it first came out, that's what basically led to the demise of the recording industry. That's why people don't buy CDs anymore. That's why all that stuff is gone. And in the mid-90s, it was, you know, you could share music with other people and all that. And eventually some artists got in there and sued. For example, when Radiohead's Kid A album came out, I want to say that was 94, 95, I think. It came out on, someone leaked it on Napster 2 days before it came out. Radiohead got really, really PO'd about that. Also, Metallica. Metallica was livid about their music all of a sudden being free on the internet. So they went out and sued Napster and they shut them down. But basically it opened up the whole floodgates to you guys have never purchased a CD, I bet, in your lives. Maybe one or two, you know. But yeah, back in the early days. But that's kind of that's what Napster was. It was just like a file sharing thing that made a lot of people really, really rich, but it basically rewrote the record industry.
With the guy
Yeah. No, I don't know. I don't know that one, but I've seen it. I know what you're talking about, though. Yeah. So that's a good movie. It's a good movie. The next part on here, again, as you can see, the whole idea of being able to rewrite some of these things is so that way we can simplify later. A really easy example using quotient. Again, let's say it's log base 4 of 5 over x. It's nothing more than the log base 5, or log base 4 of 5 minus the log base 4 of x. And I'm just showing you how these things break apart.
Oh,
Okay? And as we get into these examples that actually will be able to simplify in a second here, you're going to see, oh yeah, this is really simple. Because you can start using those exponent rules and you can start to simplify out. And then the last one is what we call the power property. The last one with the power property, same idea. The log base b of something raised to an exponent is you put the exponent in front of the log to the same thing. And again, one of the main reasons to be able to do that is if you had that example earlier where you had the log base 7 of 49x, we could have taken that x value out in front of it and simplified out the log base 7 of 49, and it wound up with 2x. Okay, that's what it's going to allow us to do. But we did that earlier by using the exponent rule by raising it up. It's just another way of doing it. Okay. So again, if we have log base 7, we'll just use that same one, 49 to the x. If I do that, let me scroll this up some. That tells me I can put the value of x in front of the log. And now if I have it at log base 7 of 49, can I rewrite 49 in terms of a base 7? It's what? 7 squared. So this is going to allow you to do log base 7 of 7 squared, which drops that down. You get x times 2, otherwise known as 2x. And we've done this simplification a little bit differently in the past. It's just another way of using that property. Okay. Sometimes it doesn't work as clean. Yeah.
Why would that simplify to 2x now? Like, I know doing it manually the answer is 2x, but when you're doing it like that, wouldn't it be x squared? Like the log 7.
What happens to the exponent when it has the same base? Remember, the exponent just falls? So it just becomes x times 2. Okay. The log base, when you have the same base on both of them, whatever that exponent just falls to normal length, if you want to call it. It's no longer a superscript and it's not a subscript. It's just script. All right. Let's do some examples. So I have log base 3 of 3 times 9. This one here is, excuse me, this one here is setting up for the multiplication property. Yeah.
Are you going to give us these 3 properties on the test or whatever?
No.
Or do you remember them?
Yeah. After 4 of examples of these things, they're not that difficult. When you're multiplying, what is it? What is multiplying? It's repeated addition, isn't it? Division is kind of like subtraction. You're cutting things down. Powers, you just have to remember the power rule and dropping it down. Okay. They're not as bad as it sounds. So if I write out as log base 3 of 3 plus log base 3 of 9, what's log base 3 of 3? 1. Log base 3 of 9? 2. What's 1 plus 2?
4.
Nobody likes you. Again, the reason why it's 2, and this is the same thing as saying that log base 3 of 3 squared, so that exponent drops down again, 300 plus 2. Now, could you have multiplied 3 times 9 and got 27? And then have log base 3 of 27, which is 3 cubed? It's the same answer, doesn't it? All right, so this is just showing how the properties work. Log base 2 of 4 to the 5th. If I use log base 2 of 4 to the 5th, I have an exponent rule here, correct? So if I rewrite it like that, I would have 5 log base 2. And can I rewrite 2 as a power with a base of 2 real quick? It's 2 squared, right?
Yeah.
What does that simplify out to become then? 5 times 2 is? It's another way of simplifying out.
We'll square the logs
The logs are getting you in and out of your exponents. Okay. Logs will get you in and out of exponents. And again, it's going to become more and more prevalent as we get to the point of solving equations with logs. This is just all the precursor to get there.
5 on that.
The property, the power property tells me whatever.
No, I was looking at the wrong one.
Okay. I go to the next one. Log, I'll just bring these on a separate sheet here so we have a little more room. I go log base 3 of 1/3. So it's log base 3 of 1, log base 3 of 3. Well, what's log base 3 of 1? 0. What's log base 3 of 3? What's 0 minus 1?
Wait, why is the second one to the third?
It's not to the third power. This is log base 3 of 3.
Oh,
It's log base 3 of 1. But then again, we probably knew that, because what's 1/3 rewritten as a base of 3? Isn't it 3 to the negative 1? Oh, you know how much that works. It's just another way of doing it. Okay? That one looks scary. There's more than one thing going on here, isn't there? What could you do? I mean, there's a couple things you can do right away. What can I do right away?
You can cube up with the first
What?
split on the numerator and then do quotient property.
What's that? What if, I can do the quotient property, but what if, look at the base right away. So how would I rewrite the 1/5 as a base 5? Okay, so wouldn't that just become, I mean, there's more ways of doing it. I mean, you can go that way, so it's log base 5. Wouldn't that be 5 to the negative 3 then? Do you guys agree? If I rewrote that?
Wait, why?
What's your answer? Do I know?
Why is the 5?
If I rewrite 1/5 as a base of 5, isn't that 5 to the negative 1?
Yeah.
All I do is
Oh,
just
you
multiply.
change.
Yeah. So I mean, so your answer would be negative 3. There's going to be multiple ways to get some of these
Can
properties.
you go over that one?
Whenever I rewrite, when I have a fraction like this, I'm going to rewrite that as a base 5. Isn't this the same as saying 5 to the negative 1? And all I did is I just multiplied it with the exponent here. Because that's what it was telling me to do. I would just simplify it a little bit differently this time. There's, like I said, there's more than one way to set these things up.
The log.
What this is going to let us to be able to do is to expand out weirder looking things. And the reason why we are going to get to that is eventually when we get to solving equations, we're going to have to be able to pick apart some of the logarithms. Sometimes you'll be able to solve for each bit of piece to help simplify it out a little bit cleaner than you can with others. So if I'm looking at this example here, I have log base 2 of 7x to the third divided by y. Now, in this property, do you guys all agree that there is a whole bunch of junk going on?
Yes.
Okay. Now, when I rewrite these things out, I'm going to split it just how it is right away. See how there's a division symbol in there? I'm just going to rewrite it as the log base 2 of 7x cubed minus the log base 2 of y to start with. I've broken the division. Now I break it into the addition parts. Now I can break it into the log base 2 of 7 plus, does everybody agree it's going to be log base 2 of x cubed?
Oh.
When I, for the addition part? Can I rewrite that as 3 log base 2 of x right away?
How'd you? Boy, how do we
I'll write it out here. Log base 2 of x cubed minus log base 2 of y. Again, I'm splitting that apart into addition. And what I was gonna do is just shortcut the exponent rule right there. If you don't want to, you don't have to. And that leaves me with log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. And that's expanded.
Yeah, that's the whole thing. That's it.
Okay.
How do you know when you're done?
When you can't do anything else.
Go backwards.
It's really, going backwards is easy. Yeah, and then what's multiplication then? And then repeated addition? Would that be, you're right, the log base 2 of x plus log base 2 of x plus log base 2 of x, and there's 3 of them, that's 3 times the log base 2 of x.
You don't have to do that.
Nah, you just leave it like that. No. I agree, it could be more expanded, but then again, I could also do this and make it more expanded as well.
Isn't that 3 log base 2 of x?
Yes, sir.
How did you go from x cubed to 3
Right here. The power rule, whatever the variable, the exponent is, it just drops out in front, and then that's how it becomes. Okay. Wow, I thought that was clever. It wasn't. Try those couple. Try those real fast. We're just gonna expand them out, okay? It's just log base 6 of 3
Log base 6 of x.
plus log base 6 of x.
And that's all you have to do.
That's it.
Okay, cool.
Again, the reason why we're doing this is going to get us to the precursor of what we're doing tomorrow when we solve the equations. Because that'll allow us to be able to get x by itself by taking logarithms and moving stuff around.
I was doing a lot.
Oh, that's right. Well, we are moving them. We're moving logs around.
I thought we were making a log 4.
We are kind of. We're expanding. We're using lots of logs, so we're using more and more logs, right? It is a very lame fort, I agree. Log base 2 of x minus log base 2 of 5. We okay on that? Let's go the other direction. Condensing. Condensing tends to be a little bit weirder. Condensing can be a little bit weirder, but you just have to be very careful about what signs you see right off the bat. So if I'm going to condense the log of 6 plus 2 log of 2 minus a log of 3, first of all, what's my base? 10. Good. So I don't have to worry about writing that down. Now, does everybody see how there's an addition symbol and a subtraction symbol? So that tells me what's happening somewhere. Division. There's some division going on. We agree?
Yeah.
So I'm going to have log of something with the division. What is it being divided by?
Oh, it's log base.
So it's just going to be 3. Everybody agree? Okay. Now, in the first one, there's multiplication because of the plus sign. Do you agree?
Yes.
It's 6 times what?
2 squared.
Perfect. That's it.
Wait, where did you? Doesn't have to write 2 squared.
I would, for right now, leave it as 2 squared just so you see what's going on here. Again, where did this come from? This came from, in here, there's an addition sign, which means that there's going to be a multiplication. It's this number times this number. This being out in front means it comes up here for the x one.
I didn't see the first one. I thought it was plus 2 on 2.
Oh, okay, I got you. Yeah. All right, yes, sir.
I have a question. When you make it longer and you get like the log of base 10 with like 6 or something,
Yeah.
would you have to like separate it further and have like log base 10 of 3 plus log base 10 of 3?
No.
You can just leave it as
You can leave it at 6. Yeah. Usually leave it at 6. I'm trying to think if they simplified it off of here. Yes, sir.
I was gonna ask if we needed to simplify it.
I don't think the book goes further on that one because this, if you simplified it out any further, you get what, log of 8. Is that right? I don't think they did. Yes, sir.
How does that 2 log 2? How is that 2 squared?
See on the other side, I've got the exponent rule, where it's n log base b to the u. The n is the exponent of u. So the book does, when you're condensing, if you have numericals here, guys, if you have numericals, the book does condense this further, where you do get log base, well, this becomes 2 times 4, and you get log of 8. Okay, it does, when you have numericals like that, you can simplify it out, right, simplify it out. But you don't have to write 8 as log base 2 plus log base 4. Yeah. Okay. Try one of those. Let's do 18. Try 18 now. Oh man. Wednesday, like silly Wednesdays.
So is it gonna be like, isn't this gonna be like simplifying, doing the condensing and then word problem?
Yeah, you know what, we will split this into 2 days, because I forgot today was Wednesday, so we're not gonna have as much time to get through more of the complex ones. What I wanna do here, did you guys get log base 4 of 5xy?
Yeah.
Okay. What I want you guys to try here are, I gave you a couple of the ones where you're just simplifying straight out using properties. I gave you 4 expands and 3 condense. Tomorrow we'll get into a little bit more of the complex ones, as well as what we call a change of base. So we will stretch this, we might as well just stretch it to 2 days. We won't get our log roll on tomorrow maybe, we'll just continue our log forts.
So when are we gonna log out? I'm still gonna complete that month.
You can log out, that's good, I'll give you that, it's good, we'll get that at the end of the